In this video, I'm going to be introducing indices. Indices are sometimes called powers or exponents, you might know them, but we are going to be talking about the basics, so what they are, and some of the simpler laws, so the first three more simple laws of indices. There are actually more laws and more uses for indices, which you can see in my next video, but for now we are just going to introduce them and look at the simple laws. All indices are a useful and succinct way of writing large numbers. They are written as a superscript, so for example, if we have 3 with a superscript 4 here, the 4 is actually the exponent or power or index, and 3 is called the base. I'm going to just call them powers from now on, but whenever I talk about power, I am also referring to what you might know as an index or an exponent. But whenever you write a power, it has to have a base. So the power is the small floating number, the superscript number, and the base is the large number. So what this means is the 4, the power, simply tells us how many times we are using the base in a multiplication. So we are using this 3 4 times in a multiplication. So 4 3's all multiplied together. In this case, if you do the multiplication, you get the answer 81. So 3 to the power 4 is a succinct way of writing 81. Now, for this example, it's not that useful. 81 is easier to comprehend and makes more sense. But when you need to deal with extremely large numbers or algebra with lots of multiplication, powers are a very useful and succinct way of expressing what you need to do. So we would say 3 to the power of 4. So if we had 27 and a superscript 7, that is 27 to the power of 7, which means that we would need to use 27 7 times in a multiplication. So 27 times 27 times 27 times 27 times 27 by 27 by 27. So you can see that actually saying 27 to the power of 7 is a lot easier and a lot quicker to know how many times you actually need to multiply the 27. So there are 2 powers that have special names, which you may have heard it. For example, 4 to the power of 2, we also say 4 squared. So a power of 2 is also called squared. And for example, 2 to the power of 3, we would also say 2 cubed. So a power of 2 is often called squared. Calling it a power of 2 isn't wrong, it's just we often call it squared. And a power of 3 is cubed. You need to be careful with powers. There are a lot of common mistakes that are made. One of the more common and simpler mistakes is to simply say that 4 squared is 4 times 2, which would be 8. 4 squared, remember, actually means that you need to use 4 in a multiplication twice, so we need 2 4's multiplied together, which is 16. Clearly, 8 and 16 are not the same. 4 squared does not mean 4 times 2, it means 4 times 4. Similarly, 2 cubed, a common mistake is that people would think that that means 2 times 3, which is 6. However, it does not mean 2 times 3. It means that we need to use 2 3 times in a multiplication. So 2 times 2 times 2. 2 times 2 is 4, times another 2 is 8. So you can see that they are not the same thing. You need to make sure you understand exactly what a power is telling us, and it is simply telling us how many times to use that number in a multiplication. Again, another common mistake or a common misunderstanding of the definition is that people describe a power as how many times to times the number by itself. And that would mean that some people think you start with 4 and then you times it by 4 twice. So they would actually end up with 4 times 4 times 4. Now we know that we have used the 4 3 times in a multiplication here, so that would actually mean 4 cubed. So just be very careful with the definition. It is not how many times you times it by itself. We don't start with 4 and times it by itself twice. We do not do that. 4 squared means that we use 4 twice in a multiplication, so it is simply 4 times 4. You have started with 4 and multiplied it by 4 once, so you have used 4 in a multiplication twice. So 4 to the power 1, again, if you think of that as how many times you multiply 4 by itself, a lot of people would say that's 4 times 4, but we know that is 4 squared. 4 to the power 1 means you just use 4 once, so it is simply 4. So any number that does not have a power effectively has an invisible 1, Any number on its own, if you want to know what the power of that is, there is no power there, the invisible power is 1. So to check that you understand what an index or power really means, pause the video and have a go at answering these questions without using a calculator. So 5 cubed means that we need 5 3 times in a multiplication. 5 times 5 is 25, times that by 5 again is 125. 8 squared means that we need 8 2 times in a multiplication, and 8 times 8 is 64. 10 to the power 4 then means that we've got 10 4 times in a multiplication. So 10 times 10 times 10 times 10. 10 times 10 is 100, times it by 10 again is 1000, times by 10 again is 10,000. So 10 with a power is actually very useful. If it is a positive whole number power, then it tells us how many zeros there are. So 10 to the power 4 is a 1 with 4 zeros. 2 cubed means that we need 2 3 times in a multiplication. So 2 times 2 times 2. 2 times 2 is 4, times 2 again is 8. And be very careful there, a lot of people get this one wrong and think 6. It is actually 8. So now we know what a power means, let's have a look at how we can use it in algebra. And it is actually very useful for simplifying down some algebraic expressions. So for example, a times a times a, we can simplify that down because we have used a 3 times in a multiplication, so that is the same as a to the power 3 or a cubed. Similarly, b times b times b times b times b, we have actually used b 5 times in a multiplication, so that is the same as b to the power 5. So you can see that actually b to the power 5 is a lot easier and quicker and simpler to understand than b times b times b times b times b. So let's have a look then if we started off with a squared times a cubed. A squared, remember, means that we are using a twice in a multiplication, and we are timesing that by a cubed, which means that we are using a 3 times in a multiplication. So we can actually simplify a squared times a cubed down, because altogether we are using a 5 times in a multiplication. Now if we have a look at another example, if we had f cubed times f to the power 5, f cubed means that we are using f 3 times in a multiplication, and we are timesing that by f5, which means that we are using f 5 times in a multiplication. So altogether we have 1, 2, 3, 4, 5, 6, 7, 8, so we are using f 8 times in a multiplication, so we have f to the power 8. Now some of you may have noticed the shortcut here. Because the power tells us how many times we are using it in a multiplication, if we have the same base, so in this first example our base was a, multiplied together, the first one tells us we are using it 2 times in a multiplication, the second power tells us we are using it 3 times in a multiplication, so altogether we are using it 2 plus 3, which is 5 times in a multiplication. In our second example the bases are f, so if we are using f 3 times, and then 5 more times, altogether we are using it 3 plus 5, which is 8 times in a multiplication. So more generally, if we are multiplying two numbers with the same base, then we can simplify that down by simply adding the powers, because m tells us how many times we are using it in the multiplication, n tells us how many more times we are using it in a multiplication, so altogether we are using it m plus n times. Let's just have a quick look at a common mistake. If we had, for example, a cubed times b to the power 4, a very common mistake is to say that that is ab to the power 7, a times b, and then you add the powers to get 7. That is not right. Remember, a cubed means that we are using a 3 times in a multiplication, b to the power 4 means that we are using b 4 times in a multiplication. So actually, if we look at that, all we can say is that we've got a cubed times b to the power 4. We cannot simplify this down. A times b to the power 7, what we had here, would actually mean a times b 7 times. The 7, the power, is just with the b, so that would mean we have a times b 7 times. So 1, 2, 3, 4, 5, 6, 7. Clearly not the same as a cubed times b4. You may have also thought your answer would be ab to the power 7, but that actually means ab times ab 7 times. So remember, AB just means A times B, so this means that we've actually got A 7 times and B 7 times. Again, nowhere near our original expression of A cubed times B to the power 4, which meant we used A 3 times and B 4 times. So just be really careful. You can only use the indices laws if your bases are the same. If they are different bases, you cannot simplify them. So we've looked at what is happening if we are multiplying two numbers with the same base, but what about if we are dividing two numbers by the same base? Now, a to the power 5 divided by a to the power 3, it is simpler to understand if we write it as a fraction. Remember, a fraction is just a division, so this also means a to the power 5 divided by a to the power 3. Now, if we think about what a to the power 5 means, it means that we are using a 5 times in a multiplication. So we've got a times a times a times a times a on the top, and we are using a 3 times in a multiplication on the bottom. Now, to understand this bit, you need to understand equivalent fractions, but as long as you do the same to the top and the bottom, then it is still an equivalent fraction. If you don't understand that, then watch my video on fractions, but we can actually cancel down 3 of the a's on the top with 3 of the a's on the bottom, because remember, a times a is the inverse to a divide by a, so a divide by a cancels out a times a. So 3 of the a's on the bottom cancel out 3 of the a's on the top, and you are left with just a times a, which is a squared. So if we have a look at another example, b cubed divided by b, remember b on its own is b to the power 1. So on the top of our fraction, we've got 3 b's in a multiplication, and on the bottom we just have 1. So we can cancel out 1 on the top with 1 on the bottom, and we are left with b times b, which is b to the power 2, or b squared. So remember, a power tells us how many times to use the number in a multiplication, and division is the opposite of a multiplication, so cancels it out. So in our original example up here, a to the power 5 divided by a to the power 3, 3 of our original 5a's are cancelled out, and we are left with a to the power of 2, which is 5 minus that 3. And again, in our second example, we had b used 3 times in a multiplication, and we are dividing that by b to the power 1, so we are cancelling out one of those multiplications, and we are left with 3 minus 1, which gave us our b to the power 2. So more generally, if we have a to the power m divided by a to the power n, we have a to the power m minus n, because n lots of the multiplication are cancelled out by this division. So the general rule is, if we are dividing numbers, again with the same base, then you can subtract the powers. So there is one more law that we can look at just from our basic definition of powers, and that is if we have an a squared to the power 3, or more generally, something to a power and then raised to another power again. Now remember, a squared means that we are using a twice in a multiplication. So this is effectively the same as a times a cubed. Now this cubed tells us that we are using everything in the brackets 3 times in a multiplication. So we are using the a times a 3 times in a multiplication, so we are multiplying those all together. So in total we have 2, 4, 6, so a to the power 6, or a 6 times in a multiplication. So let's do another example, b to the power 5 all to the power 4. So this bit means that we are using b 5 times in a multiplication, and then we are doing that 4 times in a multiplication. So we have 5 b's all multiplied together 4 times. So in total we have 5 lots of 4, which is 20. So if we wrote that all out, we would end up with 20 b's in a multiplication, or b to the power 20. So the second power tells us how many times we are using all of the b's from the first power. A common mistake that people make at this point is they add the powers. So they would say that b to the power 5 all to the power 4, you do 5 plus 4 to get a power of 9. But remember, b to the power 5 all to the power 4 is not the same as b to the power 5 times b to the power 4. We are not using b 5 times in a multiplication and then 4 more times in a multiplication. We are using b 5 times in a multiplication, and we are doing that 4 times. So we need to multiply the 5 and the 4, not add them. So as a general rule, if we have a to the power m all to the power of n, that is the same as having m lots of n, so m times n, lots of a in a multiplication. So if you have a power and then another power, the general rule is that you multiply the powers, and you will often just see the law written like this, because remember, in algebra, mn means m times n. Okay, so let's have a quick look at some examples of how we can use our power laws. So 12 to the power 4 times 12 to the power 10. This means that we are using 12 4 times in a multiplication and then 10 more times in a multiplication. So in total we are using 12 14 times in a multiplication. Question 2, we are using 3 7 times in a multiplication and then dividing it by 2 used 4 times in a multiplication. So because the bases are different here, we cannot simplify it. Dividing by 2 does not cancel out a timesing by 3. So this simply stays as 3 to the power 7 divided by 2 to the power 4. Because the bases are different, you cannot simplify it down. Number 3, which is 3 to the power 4 all to the power of 8, means that we use 3 4 times in a multiplication, and then we do that 8 times all multiplied together. So in total we've got 8 lots of 4, which is 32 3s all multiplied together, so 3 to the power 32. Number 4, we've got 5 used 6 times in a multiplication and then 4 more times in a multiplication, so that is 10 times in a multiplication, and then that is divided by 5 to the power 2, so 2 of those times by 5s are cancelled out, so 10 take away 2 is 8, so we are left with 8 5s all multiplied together, or 5 to the power of 8. Number 5, this often confuses people because we have numbers and letters in there. Remember, this on the top means that we have 8 used 7 times in a multiplication, and then that is multiplied by 42. It does not mean that we have 42 used 7 times in a multiplication. The power is just with the h. If we wanted it to be with the 42 as well, we would need to put it all in brackets like that. But because it is not in brackets, this means 42 times by h times h times h times h times h times h times h. So on the bottom then, that means that we've got 7 times by h 3 times. So we can actually do the number part, so 42 divided by 7 simplifies down to 6, because 42 divided by 7 is 6. And then we are using h 7 times, but we are cancelling out 3 of those by dividing by h 3 times, so that leaves us with h to the power 4. So remember, the power is only with the immediate thing it is next to, in this case the h, and the other parts can be treated separately. So similarly with number 6, this means that we've got 7 in the multiplication once, a in the multiplication 3 times, 9 in the multiplication once, and then a in the multiplication 9 more times. And remember, the order of multiplication doesn't matter. It doesn't matter if you do 2 times 3 or 3 times 2, you will end up with 6. So we can actually multiply the number parts first. So we've got 7 lots of 9, which is 63, because remember, we are only multiplying by 7 once and 9 once. But then we are actually multiplying all of that by a 12 times. So we have 3 times here and 9 more times here. So again, you can multiply the number parts and the power parts or algebraic parts separately, and the answer to that is 63a to the power 12. Number 7 then is in brackets, so this means that we actually use the 2a 3 times in a multiplication. So we use the 2 3 times in a multiplication and the a 3 times in a multiplication. So we could write this as 2 cubed times a cubed, which means we've got 2 used 3 times in a multiplication times by a used 3 times in a multiplication. 2 cubed is 8, and then in algebra we don't use the times sign, so 8a cubed. So 2a all cubed is actually the same as 8a cubed. So finally, number 8, x to the power 4 times x squared means that we use x 4 times in a multiplication and then 2 more times. So that's x to the power 6 divided by x to the power 6. So all of the multiplications in the top are cancelled out by the multiplications in the bottom, and we are actually left with x to the power 0. Now x to the power 0 technically means that we use x no times in a multiplication, and this is really commonly misunderstood, so we're going to just have a look at what the power 0 means in a little bit more detail. So we're going to just talk about exactly what x to the power 0 means. Now we've just said that if we have x to the power 6 divided by x to the power 6, using our indices, you do 6 take away 6, and that leaves us with x to the power 0. Now, if we think about a division, if you have something and divide it by itself, so if we had 3 divided by 3, or 7 divided by 7, or 100 divided by 100, in all of these cases the answer is 1. How many 3's are there in 3? There is 1. How many 7's in 7? There is 1. How many 100's in 100? There is 1. So x to the power 6 divided by x to the power 6 must be 1. So this means that x to the power 0 actually equals 1. It is a really common mistake that people think that x to the power 0 would be 0 because they think, well, we use x no times in a multiplication. But if you think about x squared, so we've got x times x, so technically that means we have one lot of x squared, or we are doing 1 times x times x. So if we are using x no times in a multiplication, that just means we have 1 and then no x's. Another way of thinking about it is, you know that x divided by x is 1. You would never answer that as 0. And remember, x divided by x means x to the power 1 divided by x to the power 1, which is also x to the power 0. If you don't like these explanations, there is another way that people like to think about it, is if we look at the pattern of what happens. If we have 3 to the power 4, that means 3 times 3 times 3 times 3, which is 81. If we have 3 cubed, that means 3 times 3 times 3, which is 27. If we have 3 squared, that means 3 times 3, which is 9. So if we look at what's happening between each term, we are dividing by 3 as we move down. So to get from 27 to 9, we divide by 3. So our next term, 3 to the power 1, if we divide 9 by 3, we get 3. And we know that 3 to the power 1 is 3. So to get the meaning of our final power, which is 3 to the power 0, we need to divide 3 by 3, which is, of course, 1. So whichever way we look at it, we always end up with this definition that anything to the power of 0 is 1. So just be really careful with that. It is not 0. Anything to the power of 0 is 1. Except for 0. 0 is the one case where this does not work, because if you try to do 0 to the power 0, your calculator will actually tell you that is a maths or syntax error, because anything to the power of 0 is 1, but 0 to the power of anything is 0. So 0 to the power of 0 is actually undefined. It is the one base that does not give you an answer of 1 when raised to the power of 0. Now, this pattern actually leads us on to a law where we can use negative indices as well, and it is also possible to use fractional indices. Now, they are difficult to comprehend in terms of the number of times you use the base in a multiplication, because if we have b to the power of minus 2, for example, how can you use b minus 2 times in a multiplication? Or even more difficult to understand, minus 3.5 or minus 7 over 2, that would be, how can you use x minus 3.5 times in a multiplication? So negative and fractional powers can't really be understood in exactly the same way, in that it is how many times you use the base in a multiplication, but their meaning can be compared and derived from that meaning, and that is looked at in another video. So you can have negative and fractional indices. I don't want you to think that you can't, but we will cover that in a separate video. So for now, check your understanding of the basic rules of indices, pause the video, have a go at simplifying these 9 questions. So number 1, it is multiplication, so we add the indices because the first one tells us that we use 5 6 times. The second term tells us that we use 5 3 times, so in total we have used 6 plus 3, so 9, so 5 to the power 9. 4 to the power 8 divided by 3 squared. Remember, the bases are different and our laws only apply when we have the same base, so we cannot simplify this down anymore. So it is just 4 to the power 8 divided by 3 squared. 6 cubed times 6 squared over 6. Remember, 6 is the same as 6 to the power 1. So on the top we've got 6 3 times and 2 more times, so we use it 5 times in a multiplication, and we are dividing that by 6 once. So the 1 cancels out one of the ones on the top, so 5 take away 1 is 4. So our answer is 6 to the power of 4. Number 4, this 4 tells us that we use 7 squared 4 times, and 7 squared is using 7 twice. So we use 7 4 lots of 2 times. 4 times 2 is 8, so it is 7 to the power of 8. We multiply the 2 and the 4. 2a cubed times 4a squared. Remember, the 2 and the 4 are only used once, so 2 times 4 is 8. The a is used 3 times and the other a is used twice, so we are in total using a 3 plus 2, which is 5 times. So you times the numbers and then add the powers because they are with the same base, so 8a to the power 5. Number 6, again we are taking 36 and dividing that by 4, so that is 9. And then on the top we have d used 5 times in a multiplication, and on the bottom we have it used 4 times. So 4 of the d's on the bottom cancel out 5 of the d's on the top. So 5 take away 4 is 1. And remember, we don't need to write a 1. D to the power 1 is just d. So our answer is 9d. 7, then 3a squared means that the 3 is used twice in a multiplication. So we've got 3 times 3, which is 9. And then the a is used twice in a multiplication, so that is a squared. So 3a all squared is the same as 9 lots of a squared. Number 8, on the top then we've got y used twice multiplied by y used 5 times in multiplications, so in total we are using y 7 times to add 5, and we are dividing that by y to the power 7. Now y to the power 7 divided by y to the power 7, you subtract the powers, which is y to the power 0, but that is also equal to 1. So our final answer, either of those are correct, but the better way to write it is just 1. That is simpler than writing y to the power 0. Number 9 then, I put that just to test you a little bit. We are adding here, so we are using a 3 times in a multiplication, and then adding it to a twice in a multiplication. So because it is adding and not multiplying, we cannot simplify it. It is a used 3 times added to a used 2 times. So our indices laws, you cannot combine it if it is a plus or a minus. They only work if you are multiplying or dividing. And because a cubed is different to a squared, you cannot simplify it. So that is just a cubed plus a squared. Before we finish, let's just have a quick look at 2 more examples that sometimes confuses people. So if we had, for example, 2 to the power 4 a cubed all to the power of 5. Some people would try and add the 4 and the 3 inside the brackets because we are multiplying 2 to the power 4 times a to the power 3. But remember, we cannot do that because they are different bases, so we cannot simplify what is inside the brackets. If we then want to get rid of the brackets, remember a power raised to another power means we multiply the powers. So this would mean that we use 2 4 times in a multiplication, a 3 times in a multiplication, and we actually do that 5 times. So we are going to use the 2 4 times 5 lots of times, so 4 lots of 5 is 20. And we are going to use the a 3 times and do that 5 times, so 3 lots of 5 is 15. So you can actually do it individually. Do the 4 times the 5 for the power of 2, and do the 3 times the 5 for the power of a. Another example that people commonly get wrong is if we have something like this. You could multiply it out and do 4 times 0, which remember is 0, and then we know that anything to the power of 0 is 1. Or you could have done it straight away. We have y to the power 4, and that is all to the power 0. Anything to the power of 0 is 1, so we could have gone straight to 1 there. But just remember that 4 times 0 gives you a power of 0, and that gives you an answer of 1 and not 0. So I hope you now have a good understanding of what a power means and how you can use the basic laws of indices to simplify expressions or equations. So just as a quick recap, if you are multiplying numbers with the same base, so remember these laws only ever apply if the base is the same, but if you are multiplying numbers with the same base, you add the powers. If you are dividing numbers with the same base, you subtract the powers. If you have a power raised to another power, then you multiply the powers, and if you have anything to the power of 0, then the answer is 1 and not 0. So have a look next at my video on the more advanced laws of indices, which include negative and fractional powers. And good job, and I will see you again soon.